Yo people, so I'm sorry I'm not able to be here today, but I still wanted to move on and talk about a new topic. So this is within data representations. There are several things I want to talk about with you guys, and the main one I want to lead up to is grouped frequency data. And so we need a data set, and we're going to do some things with it. We're going to review some concepts, and then we're going to get to grouped frequency very soon. So let's go ahead and get a data set. This data set, it doesn't really matter what it represents. It's just a data set that represents some measurement that happened. Here's what our data set is. And you do need to copy it into your notes. I'd love, like, these are notes. Copy them into your notes. Let's use them. Data set looks like this. Data set is 18, 20, 22, 22, 22, 22, 23, 23, 24, 24, 25, 25, 25, 25, 25, 25, 26, 26, 27, 30, 30, 31, 35. Cool, so here's our data set. The first things I want to do are just review some things that we should, in theory, already know. So, question one, I'm going to say, let's go ahead and draw a stem and leaf diagram. So, a stem and leaf diagram could look like multiple things, but on the IGCSE, it's always the exact same. What stem and leaves always have is they always have stems on one side and leaves on the other. These stems could be lots of different things, but on the IGCSE, the stems are always 10s and the leaves are always 1s. So first thing, I'm just gonna look up at our data and say, what are the 10s that we have? Well, the lowest 10s we have is 10. Like 18 is 10 and 8. So I'm gonna put 0 10s, but there are no 1s. There are no data points that are there. But in the 10s, we have 18 and 18, and then we're into the 20s. So there's 18 and 18. And these two 8s represent the fact that there are two 18s. And then I would move into the 20s. So in the 20s, great, I've got 20, 1, 2, 3, 4 22s. So 20, 1, 2, 3, 4 22s, 1, 2 23s. And I shouldn't put them so close. And then 1, 2 24s. Maybe I'll start a new line. 24, 24. 1, 2, 3, 4, 5, 6 25s. 1, 2, 3, 4, 5, 6 25s. 1, 2 26s. 27. And then I'm into the 30s. So now my 20s are done, and I can move into the 30s. This was 0s, 10s, 20s. And then 30s, we have 30, 30, 31, 35. So 30, 30, 31, 35. This is a stem and leaf. For IGCSE, you have to know how to interpret a stem and leaf. So you have to be able to look at this stem and leaf and tell what the data looks like. Well, you can see there's a whole bunch of 20s, and then there's like, I don't know, a few in the 10s and a few in the 30s. You can, in a sideways way, you can kind of almost see like this is kind of bell curve-ish, like a little bit. So it's just kind of a visualization of the data. Why won't you undo? Weird. Well, whatever, I guess the purple's there now. So it's just a visualization of the data. You need to be able to read it. On the IGCSE, they will always ask the same things following this. So I'll call this like 2A, B, and C. The thing they always ask is mean. Oh no, they usually ask the mean somewhere else. They ask for median, mode, and range. So to find the median is the middle value. So we can go ahead and find the middle value. I would just say this is the highest value and this is the lowest value. And so we want to find the middle value. In some sense, those just kind of cancel each other out as we move in towards the middle. So then this guy and this guy cancel next, and then 30 and 20 are next, and then 30 and 22. My next below 30 is 27. So 27 and 22 cancel, 26 and 22, 26 and 22, 25 and 23, 25, so 25 and 23, 25 and 24, and we can see we're going to end up with 25. Those are in the middle. For the median, then I would take those 20, like there are 2 data points in the middle that are both 25, so it's clearly 25. But if these were different data points, I would take 25 and 25, and I would average them. And in this case, we get 25. So that's our median. The mode is the most common. So to find the mode, I'll do mode with yellow. So find the mode, I would just think there are 2 of these 8s. But there are a whole more. There are 4 22s. There are 2 23s, 2 24s. Clearly it's going to be 25. There's 1, 2, 3, 4, 5, 6 25s. So that's more than any of the others. 25 then is the mode. And this is a common way also that we measure the center of data. The range is the space between the space between the highest and the lowest. So we could calculate it by doing the high minus the low. Well, our high is 35, our low is 18, so the range is 35 minus 18, which is 35, 25, 17. So that's the space between the highest and the lowest, like the space in the data. So great, okay, we have from a data set, we can draw stem and leaf, and these are the typical questions that follow the stem and leaf on the IGCSE. From there, I want to look at the next type of diagram that you need to be familiar with. Stem and leaf technically should be review, so I hope it is for many people, but I'll give you guys a little bit of practice, and these are the questions that will follow them. So they usually give you the data set, they want you to fill in the stem and leaf, so you do have to know how to fill in the stem and leaf, and then you have to know how to compute these things. The next thing I want to talk about is box and whisker plots. Good. 3, draw a box and whisker diagram or plot. Well, we have our data back here. Box and whisker plots, you might not know what they are in the first place. So let's give an example of what box and whisker plots are and look like. What they are is they will have a box with a line somewhere, and then they'll have whiskers. The way they work is that in each section, like in this section here, there's 25% of all of the data points. And then in this section here, there is 25% of all of the data points. And in this section, 25% of all the data points. And in this, 25% of all of the data points. So you're splitting the data into fourths, which means this is the exact center. So we can already see this here is going to be the median, which is great because we've already calculated that. This down here then is going to be the lowest, and this is going to be the highest. And we already have those things. The things we don't have is basically above the median over here. Why not highlighter? Above the median over here, we need to find this spot. Well, if 25% of the data is here and 25% of the data is here, this is just basically the median of the high end. And that's what we call it. It's the upper quartile. Because it's basically saying like the lowest 25% and then the kind of the next 25% and the third 25%. This is like the 75th percentile. We also have another name for it. It is quartile 3. Both of those are normal. And so this one down here is the lower quartile or quartile 1. So in our case, with our data back there, we already know the low, we already know the high, we already know the median, but we need to find quartile 1 and quartile 3, which is the median of the low end of the data and the median of the high end of the data. So let's go back and look at it. Our low is 18, the high is 35. Let's fill in the things we know. 18, high was 35. I can see here the median was 25. So good, we know those things. Then for quartile 1? Well, what colors have I not used? I haven't used green. The median is here circled in red. So really the median is between those two datas, or between those two pieces of data. So to find quartile 1, I'm going to go below those two quartiles of those two pieces of data and look for the median in the bottom end. So 18 is the lowest of the bottom end, and 25 is the highest that's below the median. And then 24 and 18, 24 and 20, and then 22 and 23, 23 and 22, and then 22 and 22 are in the middle. So again, I would average those, but I can see quartile 1 is 22. And then quartile 3, I'm going to do the exact same thing on the high end. So I'll use blue. On the high end, well, 25 is the lowest above the median, and 35 is the highest above the median. So those would cancel. And then this one, and 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 this one. Just working my way in. So those and those are gone. These are the 4 that's left. I can see these will cancel, and there's my upper quartile. So I would average those. It would be 26 plus 26 divided by 2, and I get 26 is our the quartile 3, the upper quartile. So I can go ahead and draw this box and whisker then, describing that data set. This box and whisker would look like, on here, maybe I can go from 0 to, our high was 35, I'll just go up to 40. So there's going to be like 20 here, and 10, and 30. And so we have a low of 18. Well, 18 is like there. Quartile 1 is 22, like here. Median is 25 in the middle. Quartile 3 is 26. It's like right next to it. High is 35. It's out here. And then those 5 pieces make the box and whisker. So I can see the box in the middle here with the whiskers going on the outside. This does tell me a lot about that data. Like the stem and leaf kind of drew the picture of the data and I could see it, that's fine. This is a better picture of the data. Like I can tell there are the same amount of data points. There's the same amount of data points here as there are here. So these are super spread out and these are super clustered. And like in general, I would say the whiskers are super spread out and the stuff inside the box is like relatively pretty clustered compared to the whiskers, because this is 25% of all the data points, 25% of all the data points, 25% of all the data points, and 25% of all the data points. So it's, anyway, I think you understand the idea. This is a box and whisker plot, and that's what it describes. It shows like where the quartiles of the data are located. And so it gives us a nice picture of the data. Great, okay, box and whisker plots. Next thing I want to talk about is frequency diagrams. So let's draw a frequency table using class intervals. I'll put it here. Intervals of let's go 16 to 20, 21 through 25, 26 through 30, and 31 through 35. So the things I'm using this to highlight are 2 new vocab words and how they work. First is a frequency table that you don't know of before, and the second is class intervals that we haven't talked about before. So we're going to use these class intervals and draw a table, and that table is going to show frequency. So I would just start with, let's draw our table. In this table we have class intervals. So I'm just going to call these, well, these are the class intervals. If we had like a context to this, I would put that context over here. This might be like height in centimeters or something like that. But it would have some context to it if that context existed. In this case, I haven't given any context, so I'm going to delete it, but I would just say these class intervals mean things. Like this 16 through 20 is something that was measured in that data set. So we should give that measure a name up here. The other side is just going to be frequency. And it doesn't ever have a name. So I guess I'll just say like name the quantity. Just saying that whatever that quantity is, we should give it a name. Frequency is frequency. So we have 16 to 20, 21 to 25, 26 to 30, and 31 through 35. And then I just want to know what's the frequency within each. So how many data points are from 16 to 20? How many data points from 21 to 25? How many data points 26 to 30? And so on. Let's go back and look at our data. So 16 to 20, for that first section, I see 3 data points. Next section, we want 21 to 25. Well, that's here and up to 25. Yeah, including all of those. And then 26 to 30 will be the next section, including 30. And then 31 to 35 is the last section. So the first section, I see 3. The last section, I see 2. The penultimate section, I see 5. And then I see a whole bunch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 in the second section. So the frequency of the class intervals was 3, 14, 5, and 2. So I can come back here and fill in the frequency for those class intervals was 3, 14, 5, and 2. So great, we have frequency. This is a frequency table because it's a table that shows frequency. And it has class intervals. Those class intervals are how we split up the data. Next thing, let's go 5. Use the frequency table to draw a histogram. So, the idea of what is a histogram. A histogram is a subset of bar charts. So it's going to look like a bar chart displaying this information. The only thing that makes it a histogram is that the x-axis is continuous. So we could make a bar chart, for example, that shows whatever, blue eyes and brown eyes. And we'd have our bars and whatever. This would be fine. Like it would show some data. But it would not be a histogram. A histogram has to have continuous data on the x-axis. So in our case, this is a histogram because we're going to have frequency here, and then those class intervals, like whatever this name is, this is our quantity. Whether it's like height in centimeters or whatever, it doesn't matter. We're going with these class intervals, so I'm just going to start here at 16, and let's just go 16, 17, 18, 19, 20, 1, 2, 3, 24. Oh yeah, sure. 25, 6, 7, 8, 9, 30. So I guess it was 21 through 22, 3, 4, 25, 26 through 30, and 31, 2, 3, 4, 35. And then I would be displaying our frequency. The highest one is 14. So when I think about how I'm going to line this out, I would think I need to go at least to 14. Come on, maybe I'll just go up to 20. So this is 10. So 14 is like there-ish. So if I come over to 21 to 25, this is our, come on, highest bar. And there's 21, 25, cool. Then, well, I'll just keep purple. 3 for 16 to 20. So if that's 10, 3's like there maybe. 16 to 20, 21 to 25, 26 to 30, there was 5. So 5 is like there. 26 to 30. And then 31 to 35 is 2. So that was 3, so 2 is the lowest. Cool, so this is our histogram. This histogram is a little bit strange because there are gaps between the bars, and it's because these numbers are discrete. So really, like, if we look at the data, there are 2 people here and then 1 person here, but we're just drawing it as a whole bar. And then there's space between because there is no one that's between those. Like, our data is discrete. It's not continuous. But it is weird. Like, histograms usually would connect the bars and everything would be nice and connected. But in our case, this is the histogram we get. No problem, that's fine. Cool, okay. So the next thing we need to talk about is a revision of something we kind of just talked about. I'll call this 6. I want to know, A, what is the mode? B, what is the modal class? And C, use the table to estimate the mean. These are the common questions that follow a frequency table on the IGCSE. What is the mode? We've already answered. So let's go back and look, like, where did we get that? What is mode? As just a quick review again. Mode here we see as the most common. I didn't write that. Most common. And in our case, it's 25. Looking at this data, there are more 25s than anything else. Looking up here, I can also see there are more 25s than anything else. That's the mode, okay? So the mode in our data hasn't changed. Mode is still 25, great. But the modal class, this is a new idea to us. So in the table, we have class intervals. So we can look at those class intervals and tell which of those class intervals is modal. So when I look, there's 3, 14, 5, and 2. These are the frequency. This is the most common one. This is the most common class. So the modal class is from 21 to 25. So the modal class, 21 to 25. Now we're going to use the table to estimate the mean. Well, we have the data at the beginning. We could just add up all the data, divide by the number of data points, and we could find the mean. Or instead of finding the mean from there, we can use the table, but we're only estimating the mean. We can't tell the mean directly. And here's what I mean. Back here, if we didn't have the data, we only knew this. We know there's 3 people from 16 to 20, but we don't know where they are. So if we were going to take a best guess as to where are these 3 within this data interval, well, we would just guess that they're in the middle. And so when we go to estimate the mean, we're going to use that 3 and that 18. And then these 14, well, we don't know where those 14 are on this interval. So we're just going to assume they're in the middle, which is 23. And these 5 are in the middle, which is 28. And these 2 are in the middle, which is 33. So when we total up all of these data points, we're basically adding up the data, but instead of adding them up, to estimate based on a frequency table, we'll do 3 times 18, plus 4 times 23, plus 5 times 28, plus 2 times 33, and that's all of the data added up. And then the total we'll divide by is the total of the frequency. So what is that? 14, 19, 21, 24. So we're going to add up those things and divide by 24. Okay, 3, 14, 5, 2. So it was 3 times 18 plus 14, 5, 2. And the middle of the intervals, I have it here, 21 to 25, so 23. 5 times the middle of the interval, which is 28. And 2 times the middle of the interval, which is 33. Right? 31, 2, 3, 4, 5. That is lame. This should be. Why? There's 35, and this bar should go all the way over. My fault. Okay, and then this is all the total, and we're going to divide by the total number of people. I think it was 24. And so this is an estimate of the mean. Here we are estimating, if we added up all of the data points, what would we get, and dividing by the total data points. And these are estimates because we don't know if all 3 of these were at 18. It's our best guess. We don't know if these 14 were at 23. That's our best guess. Yeah, so these are new vocab ideas. These are the common questions that follow a frequency table, and these are very common on the IGCSE Extended. We have one last topic I want to talk about, and it is grouped frequency. So let's get a new set of data, and we'll use it to talk about one last idea. Okay, so this is the new data that I want to use to talk about this idea. We have a table. This is a frequency table. Number of plants is a type of frequency. So this is the number of plants that are within each of these class intervals. And we could use this table to go ahead and draw a histogram. I can picture that. It's already going to be a bar chart with these heights, and the x-axis is continuous. So it is a histogram, and that's great. I'll be honest though, you will never be asked to do this question again. And it's because we're going to draw this in order to tell it kind of doesn't make sense. There's a different thing that we will do instead. So, cool, let's go ahead and draw the histogram so we can look at like, why does it not make sense? So the histogram, great. I know this is going to be number of plants, which is frequency. I know this is height in centimeters. And I can see these are my intervals. So maybe I'll just start at 0. I'm going to go up to 40. So 20 is in the middle, 10, 30. I want 5 to 15. So there's 5, there's 15. 15 to 20, I have it. 20 to 25, there's 25. 25 to 40, I have those. So, but I guess I've gone every 5. I might as well mark this. So cool. From 5 to 15, there are 4. So starting at 5. Going to 15, number of plants, all of these are below 10. I'm just going to go up to 10. There's 5. 5 to 10, we want 4. So maybe that looks, oh no, that looks too high when I move my head. Maybe something like that is 4. I could just do this to make it clear. And then from 15 to 20, there are 8. So then 15 to 20, I'm going to go up to 8. And then 20 to 25, there are 7. And then 25 to 40, there are 6. So from here to 40, there are 6. I'm being a little bit misleading the way I'm drawing this, but it's because I want to make a point. Here's the point, is that there are 8 people here, and there are 6 people out here. But this drawing displays this really terribly. Like, these 8 people look like they're just a little bit higher in the bar than these 6 people. But these 8 people are within this space. They're like super clustered. That bar should look big. These 6 people are over this space. They're super spread out. That bar should look smaller. So that's why when we have a grouped frequency table like this, we will never draw a histogram. What we draw instead is actually still a histogram, but it's called a relative frequency histogram. This over here is frequency. And it's not relative because it doesn't account for the width of the class interval. So when we draw a relative frequency histogram, it's going to account for these widths. And here's the way we do it. First, I'm going to go ahead and add a couple columns here. We don't have to add these columns, but they're going to highlight really well what happens. I want the width of the interval, because that width of the interval is what makes this distorted. So let's look at the width of the intervals. The first one is 10, next one is 5, next one is 5, and the last one is 15 in width, because from 40 minus 25 is 15, or from 25 to 40 is 15. So the widths of each of those intervals is here. And then we're going to create what's called frequency density. If you remember when we talked about when this came up on the IGCS or E earlier, when we saw density, the clue is that you should immediately think of division. Density is like, I think it's mass divided by volume, but it's a division problem. So if we see frequency density, we're going to take the frequency and we're going to divide it by something. And so I want to take these numbers, and the thing I want to account for in this case is the width of these intervals. So I'm going to take these numbers divided by the width of the respective intervals. So here I would get 4/10. Here I would get, the frequency is 8, the width is 5, so 8/5, and then 7/5, and then 6/15. So this one is 0.4, this one is 1.6, this one is 1.4, and this one, 6/15, geez, is 3 over 5. It is 0.6. So this frequency density as a histogram should display this data in a way that looks more like more accustomed to the data, a better picture than this. So let's look at it. We have those same frequency or the same heights. So I'm going to go up to 40. There's 20, 10, 30. Here's the 5s. Great. And I know I'm not like perfect. This is height in centimeters. And then here I'm going to put frequency density. My highest frequency density is 1.6, so I'm just going to go up to 2. There's 1, and I'll do the same thing I did there. From 5 to 15 is our first class interval, and that class interval is 0.4, so it's like 0.4. Then 1.6 from 15 to 20, so 1.6 is like up here, 15 to 20, and 1.4 after that, 1.6, sure, 1.4, and then 0.6, so it's going to be 0.6. Cool. This picture is a better display of this data than this picture. And the reason is that like there are 6 people here, but they're super spread out. So this bar is distorted in its height. And there are a ton of people here and they're clustered. So these bars should be tall, but they relatively should be taller. Well, when we look at frequency density and we display that, these bars are taller in a way that represents the fact that their data is more dense. That's the whole point. There shouldn't be a gap here, but I don't think it really matters. So this is frequency density, and that'll be kind of the next place that we'll be going. So in the next assignments, the major things I'm going to ask you guys to do are draw box and whisker plots and interpret them, and then we'll be moving towards frequency tables and frequency density and histograms of frequency density.